Hello everyone. In this chapter, I will introduce hypothesis testing. Okay, it is a second part of statistical inference. We assume that you want to know the average weight of a global population. Global population. Okay, and there is a parameter mu. In this case, you can have the following hypothesis. That is, maybe mu, that is the average weight of the global population equal 50 kilogram. Okay. To prove this, we extract a sample. Okay, and perform this inference. Okay, this process is called the hypothesis testing. So let's first examine the process hypothesis testing step by step, and I will introduce the terminology use this context. Okay, that's notation. Specifically, we'll look at the case where the parameter of interest in the hypothesis are the population mean and the population proportion. Okay. Today's video lecture will introduce this topic. Okay, and in this Friday's video lecture, that is May 19, this Friday, we'll cover these two parts. Okay, this today lecture. Okay, as you know, statistical inference can be divided two parts, that is estimation and hypothesis testing. Estimation was covered in the last chapter 6. Okay, and hypothesis testing will be covered in this chapter 7. The testing means that the process used to evaluate the hypothesis related to parameters from the sample. Okay, for example, we hypothesize that the parameter theta equal the average weight mu, such as the 50 kilogram. Okay, in the weight example, in this case, the testing means using the given sample to prove this process. Okay. So in the hypothesis test, we can evaluate the strength of the evidence, the hypothesis we assume from this sample. Okay, that is, it is used to test if a statement regarding a population parameter is statistically significant. Okay. Now let's learn about hypothesis test step by step using the following example. James, who entered Yonsei University in this year. The James is known for having excellent math skills. To prove this, we gave James a total of 10 math problems. Okay? Out of this, James answered 9 correctly. Can you say that James is better at math than other students? Step 1. Stated the hypothesis. A hypothesis can be divided into a null hypothesis and alternative hypothesis. Okay, null hypothesis is the assumption or claim that there is no significant difference. Okay, and we denote by H0. So in this example, the H0, that is null hypothesis, means that James' math skills are similar to, that is, there's no significant difference those of other ordinary students. Okay. On the other hand, the alternative hypothesis is the opposite of null hypothesis. It represents the claim that there is a significant difference. Okay, and it is denoted by HA or H1. In this example, the HA, that is alternative hypothesis, is that James has superior math skills compared to other students. Okay. Since the H0 means that the hypothesis when there's no significant difference is that parameter is equal to the hypothesis value we assume, that is 0 equal etc. is hypothesis value that is constant. Okay, and the alternative hypothesis means that there is no significant difference. So it states that the parameter is smaller, greater than, or different from the hypothesis value we assume. That is, the alternative is either less than, greater than, or there has a difference. Okay. Also, we can re-express this hypothesis as follow. If James has similar to mathematical skill to other students, so the probability of him solving the problem, the probability of solving the problem would be 0.5. Okay, so the null hypothesis denoted by the H0 is the probability equal 0.5. On the other hand, the alternative hypothesis means that James has significantly better, superior mathematical ability compared to other students. Okay, so we can express as the probability greater than 0.5. Okay, and James was given a sample. Okay, sample the 10 math questions. Question 1, question 2, question 10. Okay, at this time, we let the number of questions with correct with the correct answers as a random variable as x. Okay. Therefore, 10 math questions can be considered as 10 Bernoulli trials, because in the question 1 there's 2 cases, they're correctly or not correctly. Okay. And if the h is 0, h0 is the probability equals 0.5 is the true. Since the success of probability, that is the probability of solving the problem, is 0.5, we can find that x follow binomial distribution. Okay, like this. 10 Bernoulli trials and the success of probability equals 0.5, and under h0 when the h0 true. Okay, and we can draw the binomial distribution and the PMF and its probability. Okay, and the second step is to set the significance level. It is called alpha. Okay, the meaning of significance level is the probability of rejecting the null hypothesis when it's true. Okay, and null hypothesis. Okay, and reject region is that the set or the range of the value of statistic for which the null hypothesis rejected under the significance level we set. Okay. In this example, the null hypothesis is the success of probability. That is the probability of solving this question is 0.5. Okay, which means that the proportion is the 5 divided 10. And we assume that the h is 0, true. Assumption. Okay. Therefore, the x gets close to 5 is support the null hypothesis. On the other hand, the alternative hypothesis is the probability greater than 0.25. So it support the alternative hypothesis as x increase 6, 7, 8, 10. Okay, H1 supportive. Okay, therefore the region that reject H0 maybe will exist in this part. This part is region reject H0. Okay, so how is the region that reject H0 determine mine? Okay, is it here or here? Okay, so you know the significance level, the alpha means the level at which h is 0 at with H0 is rejected. Okay, if the significance level alpha equal 0.05, then this region means the probability of x greater than 8 is in this table. We can calculate. So equal 0.0547. Okay, it is exceed the 0.05 alpha, so thus it cannot be the reject region. Okay, however, since this region, that is the x greater than equal 9, does not exceed 0.5 because this value is 0.0108. Okay. Okay, so this is reject region of H0. Okay, and if you set the alpha equal 0.1, then the reject region is this part. Okay, so under the alpha 0.05, that is this reject region, so you can reject the H0 when x equal 8 or x equal 9. No. X equal 9, x equal 10. Okay. Step 3, the calculating the test statistic. Using the test statistic, which is used in statistical hypothesis test, we can determine whether to reject AC0. That is, the statistic is criteria for selecting AC0 or not. In this example, since James answered 9 out of 10 questions correctly, the test statistic is x equal 9. Okay, and step 4, the final step, is that calculate the p-value and state your conclusion. P-value means that the probability of obtaining the test statistic as extreme as or more extreme than their observed value, assuming that the null hypothesis is true. Okay. Typically, we use the p-value to draw conclusion about the hypothesis, and therefore, since the test statistic is x equal 9. Okay, so the p-value is there x greater than equal 9. Okay, that is the sum of these two probability equal the p-value. Okay, equal 0.0108. Since this p-value is smaller than the significance level alpha equal 0.05, we can reject H0. This is equivalent to the test statistic being in the reject lesion, you know, the reject lesion. Okay, so and the test statistic being in the reject lesion. Okay, in conclusion, at the significance alpha equals 0.05, we have sufficient evidence to conclude that James has excellent math skill than other students. Okay. The process of hypothesis testing can be summarized as follows. Step 1 is to set up the hypothesis. It's very important. In this case, H0 states that James has a probability of solving math problem, that is the probability large P equal 0.5, and the alternative hypothesis is the probability greater than 0.5. Okay. Now step 2 is to set the significance level, that is alpha, which is choose as 0.05 in this example. Now step 3 involve the calculator test statistic, okay, that can determine whether to reject H0. In this case, the test statistic x equal 9. In the final step, step 4, using the obtained test statistic, you calculate the p-value, and by comparing the p-value with the significance level alpha, so we can conclude whether to reject H0 or not. Okay, in this example, we can reject H0. Okay, so the James has a superior mathematical skill than other students. Okay, let's look at another question here. It is also claimed that James has excellent Korean language skill. Okay, to prove this, 20 random Korean language questions were given to James to solve. As a result, he answered 15 questions correctly. Can you conclude that James has excellent Korean language skills? Okay, and we set the significance level alpha equal 0.1. Okay, first we set up the hypothesis. Okay, so H0 states that the probability of answering the question correctly, that is P equal 0.5. Then the alternative hypothesis is P greater than 0.5. Okay, and the second step is to the significance level. It is given as 0.1 in this example. The step 3 is to calculate the test statistic. Okay, you know the test statistic x equal 50. Okay, and under the null hypothesis, that is when the S0 is true, the binomial, the x, the follow binomial distribution is follow the 20 and because 0.5 when H0 true. Okay, therefore the p-value, the p-value representing the probability of rejecting the null hypothesis is the probability of x greater than 50. This is a test. So like this. See? The p-value. Okay, so it means that probability equal x 50, 40, 50, 20. So this value is 0.0207. Okay, since this is smaller than the significance alpha 0.1, so we'll reject the null hypothesis. Therefore, under the significance level alpha equals 0.1, we have sufficient evidence to conclude that James has excellent Korean language skill, as we will reject the null hypothesis. Okay. So far, we have examined the process of hypothesis testing step by step. Okay. In this chapter, we'll look at the hypothesis testing regarding the population mean. Okay. Consider a population with a population mean mu and the population variance sigma square. Okay. Here, the parameter we are interested in is the population mean, mu. Okay, and we can formulate the following hypothesis like this. Null hypothesis is mu equal the specific constant mu 0. Okay. For example, in the average weight of a global population, we assume that the average weight may be equal 50 kilogram. Okay, to 0. Okay. So to calculate the p-value for the hypothesis, we need to know the distribution of sample mean x bar. Okay, x bar, which is an estimator with a sample size of the small n. Okay. First, if the population x follow normal distribution and with the parameter mu, and we know the population sigma square, that is known. Okay, then the x bar also follow normal distribution, the mean mu, and the variance of x bar is sigma square divided the sample size small n. Okay, this is the equivalence, the standard error square. Okay. Okay, and it's just standard form, that is x bar minus mu over the standard error, that is sigma divided square root to small n, is follow standard normal distribution. Okay, And second, when the population follow normal distribution with the mean mu, and the population variance, the sigma square, is unknown. So we replace the sigma square with the sample variance or sample standard deviation. Okay, so the x bar minus mu divided sample standard deviation small s over square root small n to follow t distribution with the n minus 1 degree of freedom. Okay, and third case, when the population is unknown. Okay, mean mu and sigma square. Okay, and then in this case, if the sample size small n is large enough, we can use the central limit theorem to approximate the x bar minus mu sample standard deviation divided square root to small n to follow standard normal distribution by CLT. Okay. Therefore, we'll examine the hypothesis testing for the population mean based on the following three cases. Okay. First, let's examine the hypothesis regarding the population mean. The null hypothesis states that there is no statistical difference, implying that the population mean equal the specific value mu 0 value, that is the constant. Okay. On the other hand, the alternative hypothesis states that there is statistical difference. Okay, so therefore the alternative hypothesis can be classified in the three categories. Okay, category 1, a specific value that is mu 0 differs from the population mean, that is not equal. Okay, and category 2, a specific value mu 0 less than the population mean mu. Okay, category 3 is a mu 0 greater than the population mean. Okay, so the direction of reject AC0 is as follows. That is category 1. The direction is the two side, so it's called the two-side test. Okay, and in the category 2, the reject the AC0, the direction is like this. Okay, so it is called the one-side test or light side test. In category 3, the direction of reject H0 is like this. Okay, so it's called the one side test or left side test. Okay, let's look at example 1. Okay, example 1 represents the scenario where the population variance is known. Okay, so a pharmaceutical company developed a diet drug. Okay, the company claimed that the average of 4.5 kilogram is reduced if the diet drug is taken still for 2 weeks. After taking the drug for 2 weeks for 10 buyers, that is the sample size small n, the average weight decreased by 4.2 kilogram. That is x part of this sample, and we assuming that the weight loss was the random variable x to follow normal distribution with the population standard deviation sigma equals 3 kilogram. Okay. In the first step, we set up the hypothesis. Since the company claimed that the population mean is 4.5 kilogram. Okay. Therefore, null hypothesis mu 0 H0 is mu equal 4.5 kilogram. Okay, and the alternative hypothesis, mu is not equal 4.5. Okay, and now it is the two-side test. Okay, so we can find that x follow normal distribution and with the population with a mu, and sigma equal 3 kilogram, so the variance is 3 square. Okay, therefore if we assume that the null hypothesis H0 mu equal 4.5 is true, then x follow normal distribution with mu equal 4.5 kilogram, and the population variance is 3 square, that is 9. Okay, and we also find that the estimator, the x bar, follow normal distribution to 4.25, and the variance of x bar is 3 square divide the sample size, the small n 10. Okay, and under AC0 true. Okay. Like this. Next, we set the significance level. That's alpha. Okay. In this example, the significance level is set to alpha 0.05. Okay. Under the null hypothesis, is it true? The distribution of x bar follow normal distribution 4.5 over the 9 over 10, right? So we can draw this distribution. Okay, x bar. Okay, in the two-side test, Okay, two-sided test with the alternative hypothesis. S is 0, mu is not equal 4.5. So the direction of rejecting the null hypothesis is on both sides. Okay, there's the two sides. Okay, therefore we have to calculate the test statistic for this step 3. Okay, so third step is to calculate the test statistic that determine the rejection. H0 is reject or acceptance, okay, of null hypothesis. So in this example, the sample mean, the x bar is given 4.2 kilogram. Okay, here. Therefore, the test statistic is 4.2 kilogram. Okay, so the p-value is like this. Okay, the 4.2. No. The 4.2 kilogram and this side, or since the test is a two side, so this distance is 0.3. So 0.3 is 4.8. Okay, this area means the p-value. Okay, and for the convenience of the p-value calculation, so we standard it like this. Okay, so G this means the x bar minus mu equal 4.5 over sigma equal 3 square root to 10. Okay, so that is like this distribution. So the test statistic according to the x bar equal 4.2 kilogram is the 0 equal 4.2 minus 4.5 to 10, so equal the minus 0.3162 like this. Okay, so the test statistic in the standard normal is minus 0.3162. Okay, this point. So the test is two side, so we should consider this quantile. Okay, so the distribution is the symmetric, so this quantile is plus 0.3162. Okay, so we can get the test statistic is minus 0.3162 like this. Yes. Okay, so the final step, that is step 4, is the calculate the p-value by the test statistic. So the p-value is this area. Okay, it is the two-side test, so we consider that also this area. Okay, so we can get the p-value, so like this, that is the tail probability equal 0.37595. Also, this area is 0.37595. Okay, so this area is 3 multiply 2, so equal 0.7519. Okay. Based on this process, the p-value of the 0.7519 is much larger than the significance level 0.05. Therefore, we cannot reject the H0. Okay. That is, this is enough evidence to support the company's claim that the population is 4.5 kilogram. Okay. There is sufficiently evidence. Okay. Look at other example 2. It is known that the average systolic blood pressure of a hypertensive patient in hospital in Seoul is over 160. Okay, that is the mu over the 160. To prove this claim, 50 patients were selected and their systolic blood pressure was measured like this. Okay, number 1 patient, number 2 patient, and number 50 patient. Okay, and we assume that the systolic blood pressure of a hypertensive patient follow normal distribution with the population standard deviation, that is sigma equal 10. Okay, this hospital claimed that the average blood pressure of the patient population is over 160. Therefore, the null hypothesis, okay, the hypothesis that there is no difference blood pressure mean with our value 160. Okay, so mu equal 160. While the alternative hypothesis is that the blood pressure mean above the 160. Okay, so in other words, this is one-sided test. Okay, and in this problem, assuming that the blood pressure patient follow normal distribution, and we know the population standard deviation. Okay, so we have the random value of x. X means the systolic blood pressure. So follow normal distribution with mu, and the sigma equal 10. So the variance is 100. Secure. Okay. Under AC0, that is AC02, then x follow normal distribution equal 160, and the variance is 100. Okay. And also the estimator x bar follow normal distribution with the mu equal 160, and the variance, that is error, is 100 divided the sample size, the 15. And the error equal the standard error squared, that is 10 over squared 50 square. The significance level in the step 2 as set at alpha equal 0.05. And they're assuming that the null hypothesis is true. That is true, and that x bar follow this equation and 50 10 square. Okay, so we can draw the dispersion. Okay, so the direction to reject the null hypothesis is indicated here. Okay, this reject. Okay, so step 3 involve the calculate the test statistic. Okay, they're given the 15 samples, so we can calculate the sample mean. X bar is the and plus okay, divided the 50, so equal we can get the sample mean is 160.4. Okay, therefore the test statistic is the 160.4. Okay, so like this. Okay. Okay. So and the standard distribution, that is g equal x power minus take over. Okay, so like this. So their standard test statistic corresponding this value is so equal the 2.479. Okay, so in step 4 we calculate the p-value. The p-value in the direction of reject the null hypothesis is like this. So p-value, okay. So the p-value of this, the z greater than 2.479. So equal to this p-value equal this area is 0.0066. Therefore, we can find that the p-value smaller than the significance level alpha 0.05. So we'll reject. So we reject double H0. Therefore, there is sufficient evidence to support a null alternative hypothesis that may be greater than 160. This example has been selected from our supplementary material. Okay. A manufacturer of a sprinkler system used for fire protection in office building claimed that the true average system activation temperature is 130 degrees. Okay, a sample of n, small n equal 9 systems when tested yield the sample average activation temperature of 131.08. If the distribution of activation time is normal with a standard deviation 1.5, that is the sigma. Does the data contradict the manufacturer claim at significance level alpha equals 0.01? Okay. In this example, the manufacturing company claims that the average temperature of the system is 130 degrees. Okay, therefore, the null hypothesis S0 is mu equal 130. Okay, and alternative hypothesis is mu is not equal 130. That is the two-sided test. Under the null hypothesis test, the temperature follow, okay, x follow normal distribution with mu equal, and the standard deviation is 1.5. Okay, so the variance is the squared value. Okay, and additionally, we can observe that the distribution of x bar also follow normal with the 30, and the variance is 5 square over the sample size is 9. Okay, it is equal, the standard error is 1.5 over 3 and the square. Okay, under the H0. Okay, so step 2 is stat the significant level alpha. In this example, we know that alpha equals 0.01. Okay, the distribution of sample mean like this, so we can draw like this. Is square under H0. Okay, so the rejection region for the null hypothesis is the both sides. Okay, like this, rejection region of H0. Okay. Okay, so and standards this z equal x power minus 30 burn goes like this. Okay, and the sample mean x power, that is test statistic, is 131.08. Okay, so the test statistic on the G distribution is equal 2.16. Okay, this value is 2.16. Okay, so as it is a two-tailed test, it's two-side test, the p-value is like this. Okay, in the step 4, the p-value is the probability z greater than the 2.16 multiply 2, because it is 2 tail test. That is two side test. Okay. So this the probability equal. This probability is 0.015. That's multiplied to equal 0.03. Okay. So since the p-value larger than the significance alpha equal 0.01, so we fail to reject the null hypothesis. Okay. In other words, there is a sufficient evidence at a 0.01 significance level to support mu equal 130. Okay, that is it is accepted. Okay, not reject. However, if we set the alpha equal 0.05, we can reject the null hypothesis as 0. Okay. Now let's consider a case where the population follow normal distribution, but we don't know the population variance sigma square. Okay, that is there is a population and follow normal, and the mu is the parameter we are interested in, and the sigma square is unknown parameter. Okay, when we don't know sigma or sigma square, we replace it with a sample standard deviation. Okay, it is. It's 1. Okay, because it is a good estimator. The reason is that the sample standard deviation is an unbiased estimator of sigma. That is the expected value equal to sigma. Okay, and it is satisfied the consistency. Okay. In other words, when the sample size increase, the sample standard deviation converts, the probability converts the sigma. Okay. Therefore, the distribution of x bar, that is x bar minus the mu divide the small s over square root to the sample size small n, to follow t distribution with a degree of freedom n minus 1. Okay. So in summary, when dealing with the normal distribution population and unknown parameter sigma square, okay, we can use the t distribution of the estimator x bar, okay, by replace sigma with small s. Let's consider example 4 related to this topic. Okay, this example is similar to example 1 from the case 1 on sigma part. Okay, a pharmaceutical company that manufactures a diet drug, they claim that claim that they're taking the drug for 2 weeks and result in an average weight loss of 4.5 kilogram. Okay, in this case, the weight loss variable noted as random variable x. So x follow the normal distribution with the parameter mu and unknown parameter sigma square. Okay, this is unknown. Okay, and we obtain the sample mean is 4.22 kilogram, and the sample standard deviation is 2 kilogram. Okay, and with the sample size 10. So in step 1, the hypotheses are as follow. Okay, H0 is mu equal, that is the average about weight loss equal 4.25 kilogram, and alternative is mu is not equal 4.5 kilogram. So the test is two-sided. The assuming that the null hypothesis test is true, the population follow normal distribution is mu equal 4.5 and the unknown parameter sigma square. Okay, so in this case, the distribution of x power with the sample size with 10 follow x minus 5, and we replace it with the sample standard deviation small s, divide the sample size is 10. Okay, to follow t distribution with the degree of freedom is 10 minus 1 equal 9. Okay, and where the sample standard deviation is 2. In step 2, we set the significance level alpha equal 0.05. Okay, and step 3 is the calculation of test statistic. The under AC0 at x power minus 4.5 2 over, that is sample standard deviation square root the 10 is follow the t distribution with degree of freedom is 9. I need the sample size 10 minus 1. Okay, so we can draw the probability distribution like this. Okay, so in this case, the calculator test statistic for given sample mean, the sample mean is the 4.2 kilogram. So the test statistic T0, T0 is 4.2 minus 4. This equal minus 0.4743. Okay, so the step 4, in step 4, since it is the two-side test, right? Two-side test. The direction is the both side. This side is the rejected region. Okay, and the since the test statistic is minus 0.4743 or 0.4743. So the p-value is the sum of this area. Okay, so we can rewrite the probability formula like this. Okay, so this area, this probability is equal 0.3233. So the p-value is 0.3233 multiply 2 equal 0.6466. The p-value is greater than the significance level alpha, so we cannot reject S is 0. So in conclusion, the p-value is 0.6466, which is much larger than the significance level 0.05. Therefore, since the null hypothesis cannot be rejected, okay, at the alpha 0.05, so there is sufficiently evidence that the diet drug reduces weight by an average of 4.5 kilograms. This problem is case covered in our supplementary textbook. Okay, so in this example, we assume the given population standard deviation is unknown. Okay, instead, let's assume that we know the sample standard deviation as small as equal 2.3. So let's conduct a hypothesis test at a significance level of 0.01, okay, to examine the claim made by this manufacturing company regarding the average activation temperature being 130. Okay, so the hypothesis for step 1 is follow, that is H0 it is mu equal 130, and the alternative is mu is not equal 130, that is 2. SID test. Under AC 0, the population X follow normal distribution and mu equal 130 and unknown parameter sigma square. Okay, therefore the distribution for the sample mean X bar minus equal 130, and we replace it with the sample standard deviation small s over square root and the sample size 9. Okay, 9 to follow the t distribution with the degree of freedom is 8. Okay, and sample standard deviation is 2.3. And step 2 is, the alpha equals 0.01. Okay, we given the significance level in this example. And step 3 is calculating the test statistic. The under H0 t equal x bar minus to follow t distribution is like this. And given our sample mean is 131.08. So in the t distribution, the test statistic is t0 equal a minus 9, so equal 1.62. Indeed, 1.62. Therefore, the p-value is this area, this probability. Okay. So in the step 4, the p-value is the probability t less than minus 0.62 plus 2 equal multiply 2, because the symmetric the distribution is symmetric. Okay, so equal the 0.072 multiply 2 equal 0.144. Okay, you know, it is larger than our choose significance level alpha 0.01. Okay, so we cannot reject AC0. Therefore, there is sufficient evidence to support the claim made by this manufacturer company that mu equal 100. Okay. Let's review the central limit theorem for sure, CLT. There is a population and X follow, and the population have a mean mu and the variance parameter sigma square. The key point here is that we don't know the distribution of the population. Okay, in this case, if the sample size enough large by CLT, the x bar minus mu over sigma divide the square root to sample size small n, the approximate the standard normal distribution. Okay, even if we don't know sigma, we replace it the sample standard deviation small s also follow standard normal distribution, because the sample standard deviation have the constancy, okay, for sigma. Okay, this concept is the central limit theorem. So let's apply this to hypothesis testing. Let's look at example 5. Okay. This is an example related to the weight loss caused by the diet drug that we discussed earlier. Okay, example 4 and example 1. Okay. The manufacturing company, the pharmaceutical company, claim that taking the drug for 2 weeks will result in average weight loss of 4.5 kilogram. However, we don't know the distribution of weight loss. Okay, therefore, we examine the result by surveying 100 buyers, 100 consumers. So the sample mean weight loss for 100 sample was 4.1 kilogram, and with the sample standard deviation of the 3.5 kilogram. Okay. In step 1, the hypothesis are as follow. Okay, the assuming the null hypothesis test, x follow, we don't know the population distribution with the mu equal 4.25 and unknown parameter sigma square. Okay, but the sample size is 100, so enough large. We can apply the CLT, so the x power minus 4.25 divide the sample standard deviation 3.5 kilogram over square root 100 to follow standard normal distribution. Okay, and the significance level alpha is set to 0.05. Okay, and assuming the null hypothesis is true, the x bar minus bar normal distribution or follow okay. Sorry, 4.2. Okay, so in step 3 we can use this distribution. Okay, so we can draw the like this. G is in the G distribution, the test statistic is like this: the 0.1 minus 500. So we can get the minus 1.1429. Okay. So in step 2, the p-value is that since the test is a two-side, the minus 1.129, this probability plus this probability. Okay, so the p-value is 0.2531. Okay, therefore, with a p-value of 0.253, which is much larger than the significance level 0.05, therefore, since the null hypothesis cannot be rejected at the significance level, so there is a sufficient little evidence that the diet drug reduced weight by the average of 4.5 kilogram. Let's modify example 8.6. Okay, the problem we deal with the earlier. Okay, in the case 1 and case 2, this manufacturer company claimed that the two average system activation temperature is 130. Okay, and let's assume that we don't know the population distribution. However, we increase the sample size to 50, and we find that the sample mean is 131.08, and the standard deviation, the sample standard deviation, is 1.8. Okay, and under significance level alpha 0.01, the hypothesis test is like this, and step 1 is H0 mu equal 1, and alternative is mu is not equal 1. Sorry. Okay, and they're assuming that the S is 0. We can know that the X follow unknown the population distribution, and mu equal 1, sorry, and sigma square parameter. Okay, with a sample size of 50. Okay, 50, which is sufficiently large to apply the CLT. So X bar minus 130 over the sample standard deviation 1.8 divide the sample square root sample size 50 to follow standard normal distribution. Okay, and step 2, the significance level alpha equal 0.01. Okay, the distribution is like this. Okay, given that the sample mean for 50 sample is 0.8, so the test statistic small g0 equal minus 50. The value is 4.24. Okay. Okay, so the p-value is like this. So the p-value equal probability by 2. So we can get the p-value as the 0.00022, which is just smaller than the significance level, about 0.01. And therefore, we can reject H0. There is sufficient evidence to reject null hypothesis and 0.01. So there is no the evidence to support the claim made by this manufacturer company that the average system activation temperature is 130. Okay, under the given the significant level 0.01. Okay, reject. In other words, we can accept the no alternative hypothesis. The third part is testing of the population proportion. We assume that we have a population and we are interested in population proportion P. Okay. Set up. Okay. In this case, we can express the hypothesis about the population proportion in the three ways. Okay. Ways. For example, we have the proportion of the male worldwide and denoted as P. Yeah. Male. Okay, so we claim maybe 50%. Okay, that is 0.25. In this case, the null hypothesis is the population proportion equal 0.5. Okay, and the alternative hypothesis can take the three cases: the P less than 0.5, the P greater than 0.5, the P is not equal 0.5. You know, it is the two-sided test. Okay. This case is one-sided test. Okay. To perform this hypothesis test, we extract the sample with a size small n, and we examine the sample proportion. What is distribution? Okay. You know, the assuming there are null hypothesis, when H0 true, the sample size enough large, we can apply the CLT. So the P per minus 0.5 over the 0.5. Right? The approximate follow the standard normal distribution. Okay. Here, the criteria for having a sufficient large is when the n multiply 0.5 greater than 5, and n multiply 1 minus 0.5 greater than 5 are satisfied simultaneously. Okay, so in the general, the specific the proportion is P0, then we can write as follow. Okay, let's look at example 6. The cure rate of new developed Alzheimer treatment was known to be 75%. Okay, to check the cure rate, the clinical trials was conducted on 200 people. As a result, 132 patients were treated. Okay, test under significance level of 5% for cure rate 75%. Okay, here it is claimed that the proportion of effectiveness for Alzheimer treatment is 0.75. Therefore, in step 1, the hypothesis are as follow. The AC0 is the cure rate, population cure rate equal 0.75, and alternative means the P is not equal 0.75. Okay, this means the two-sided test. The assuming the H is 0, the population proportion P equals 0.75, that is 5. And first we should check whether sample size is sufficient to apply the CLT. So the condition 1 is n multiply P0, that is 200 multiply 0.75, greater than 5. Second condition is n multiply 1 minus P0, that is 200 multiply 1 minus 0.75 is also greater than 5. Okay, so we can apply the CLT. So the sample proportion minus 0.75. Follow the standard normal distribution. Okay, and step 2, the significance level is set to 0.05. The under AC0, the P bar minus follow standard normal. So okay, the given sample proportion is like this, the 132 divide the 200, right, and equal 0.66. So the test statistic in G distribution is small g0 equal 0.66 minus equal minus 2.94. Okay, so in the step 4, the p-value is to solve this probability. So p-value is calculated as equal 0.001 multiply 2 equal 0.0032. Thus, at the significance level of alpha 0.05, we'll reject H0 because the p-value less than 0.05. The question 45 is selected from the supplementary textbook. A random sample of 150 recent donations at a certain blood bank revealed that 82 were type A blood. Does this suggest that the actual percentage of type A donations differs from 40%, the percentage of population having type A blood. Carry out a test of the appropriate hypothesis using a significance level of 0.01. Would your conclusion have been different if a significance level of 0.05 has been used? In this question, it is claimed that the actual percentage of type A donation differ from 40%. Therefore, the hypothesis testing setting for step 1 is as follows. That is, H0 is the population proportion equal 0.4, and alternative is the proportion is not equal 0.4. Okay. Assuming the null hypothesis, that is under AC0, the population is as follows. That is the population proportion equal 0.4. Okay, and the sample size small n equal 150. So n multiply the p0, that is 0.4. This value is greater than 5, and n multiply 1 minus p0 equal multiply 6. It is also greater than 5. So the conditions for the sample to apply CLT are satisfied. Okay, we can use the CLT. Therefore, the sample proportion P bar follow the approximate follow the normal distribution for that, or by CLT. Okay. In step 2, we'll consider the significance level alpha 0.05 and 0.01, and we compare the result. Okay. And the distribution for P bar as follow. Equal like this. The sample proportion, the sample proportion is equal 82. So it's 0.547. So the test statistic is 0. Go 3.675. Okay, therefore the p-value is the sum of this probability. Okay, so in step 4, the p-value equal the probability plus equal 2. So the 0.0001 2 multiple 2 equal 0.00024. Okay, you know, the result lead to the reject H0. Okay, when their significance level alpha 0.05 and 0.01. Okay, in other words, there is just sufficient evidence to support the claim that the alternative hypothesis.